So, welcome. It is Thursday, October 15th, 2020. We are going to be starting Chapter 2 today and specifically talking about percentiles and z-score. If you don't know what those are, don't worry, we'll cover them today and we'll get to practice. All right, so here we go. First thing we have is just a definition of percentile. Right? The p percentile of a distribution is the value of with p% of the observations less than it. Percentiles are one way to describe the location of a value within a distribution of a quantitative variable. So when I'm at the 25th percentile, what this definition means is that 25% of the values are less than that point. Right, so we'll look at an example here. Our stem plot to the left shows the test scores for 25 students in a class. Right, they range from 67 to 93. Right, we have our key here, 72, the student who scored a 72. We want to know what percentile is the student who scored an 86. All right, so let's look at our data. In this stem plot, we have 25 students represented, or 25 observations, 25 data points. All right. We're looking at student who scored an 86. There's only one, and it's represented by this 6 here that goes along with the 8. If I want to know what percentile that student is, where that score resides, I need to know how many scores are less than 86. Remember, that's our less than part of the definition. So I need to count how many scores are less than 86 out of my 25 scores. So we'll count. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and 21, and that's where we stop. 86 does not count because 86 is not less than 86. It's equal to 86. We only want less than. So I have 21 observations or scores or students. We have 21 scores that are less than 86. Right? And so to find the percent of scores less than 86 is 21 divided by 25. The scores that are less than 86 divided by the total number of observations, number of scores, number of students. And that will get me, where did I put that? There. The result of 0.84. Right, we need to convert that to a percent. By moving our decimals 2 spots. 1, 2, gives us 84%. So 84% of the scores are less than 86. Which then means the student who scored an 86 is at the 84th percentile. So the percentile that this student is at represents the percentage of students who scored less than them. Right? That's the key way of interpreting a percentile. It tells me how many scores percentage-wise were less than that score. What questions do you have? What can I clarify? Okay. Can you raise your hand if you need a moment to write stuff down? All right, I shall pause. Next. There's a whole lot of stuff in here, but we'll make sense of it. The next slide will help out tremendously. So our next term here is cumulative relative frequency graphs. Right? To get a cumulative relative frequency, you first need the relative frequency, which is a percent, then the cumulative frequency, add the counts in the frequency column for the current class and all classes with smaller values of the variable. Lastly, find the cumulative relative frequency, where we divide the entries in the cumulative frequency column by the total number of individuals and convert to a percent. All right. These are all things that we have done before. It's just we're taking some numbers we've already found, which are frequency and relative frequency, and converting them to cumulative values. Okay, this will make more sense when we look at the example on the next slide. Right. This is a general idea of where the cumulative relative frequency will come from, which we will then use to make a graph, or we can use to make a graph. Okay. Can you please raise your hand if you are writing this down and you need more time? Okay. I shall wait. Good. All right, so here's our examples, right? We have a table and graph here, and it represents the ages of the first 44 U.S. presidents when they took office. Right? Our first few columns here, we've seen before with other examples, different values and such, but we've done these things before. We've got our age, which is broken into classes with 5 years within each class. We have 40 to 44, 45 to 49, 50 to 54, and so on. And we have the frequency, right? The number of presidents that are within each of those classes. And then we use that to find the relative frequency by dividing the number of in that class by the total number of presidents, 44, to get a percent. All right. So the first part of this table here, we've done and seen before. The cumulative frequency, right, and cumulative means we add it up along the way. It takes into account everything previous. Right? Starts the same, right? It should be 2, because there's nothing before this, there's nothing to add to it. The next one is 9, because we have to add 7 and 2. Cumulative. Everything that came before this class gets added into the cumulative frequency. Okay, so we have 2 plus 7, 9. The next one is achieved by saying, okay, well, we're at 9. We add the new 13 from the next class, get 22. 22 plus 12 is 34. 34 plus 7 is 41. 41 plus 3 is 44. The last cumulative frequency listed should be the total. Right? It should be equal to the number of observations, in this case, 44. If it is not, you made an error along the way. You forgot someone somewhere. The cumulative relative frequency is then achieved the same way as we found our relative frequency. You take the number in the cumulative frequency and divide by 44. Okay, and get a percentage. So your first percent should be the same as the relative frequency. Right, 4.5% here, 4.5% here. Then 9 divided by 44, 20.5, 22, you get 50, 34, right, and so on. And we've got all these. The last row here, the cumulative relative frequency, should be 100%, because the cumulative frequency should be everything in our set. Right? It's, could be possible maybe to have a rounding error at some point, but this last one should be 100% for all the observations. Then to make our cumulative relative frequency graph, we use these percentages. Right? And it creates what we see here, which is this kind of curve that allows us to identify percentages and percentiles. Right? So to make a cumulative relative frequency graph, you're going to plot a point corresponding to the cumulative relative frequency in each class at the smallest value of the next class. So this point here at 45 is the point for the class of 40 to 44. Right? So and that's this example. For example, for the 40 to 44 class, the point is plotted at a height of 4.5% here, above the age value of 45. Okay, that's this one here. Okay. This means that 4.5% of presidents were inaugurated before they were 45 years old. So again, this goes back to, with our percentiles, the less than aspect of it. This point that resides at 45 is saying that 4.5% of our values are less than 45. At 50, 20.5% of my values are less than 50. Right, the point that's at 55, right, 50% of my values are less than 55. Okay, so that means if if the president was 55 when they took office, they are in the 50th percentile because 50% of the presidents were younger than 55 or less than 55 years of age. Okay. So what these types of curves allow us to do is predict and place, new data points within our percentile range. They use tables like this when you do like standardized tests and you get your results back and it says you are in the 87th percentile of all students tested. That means that 87% of students score than you. Also means that 13% of students got your score or higher. Okay. So that's why we have these tables, is it allows us to put new data in and place it somewhere within our distribution as far as where it would rank, kind of like a ranking system. Okay. What can I clarify for you? What questions do you have? Okay. Can you raise your hand if you need another moment to write stuff down from this screen? Okay. Next and last slide in this part. We have our standardized score, or z-score. Right. And this is defined with the following. If x is an observation from a distribution that has a known mean and standard deviation, the standardized score for x is the following. Z equals x minus the mean divided by the standard deviation. The standardized score is often called a z-score. A standardized score essentially tells me how many standard deviations an observation is away from the mean. So it kind of helps us identify a location compared to the rest of the results. But in this case, we're relating it back to the mean. Okay. So we're going to use this example again. All right, our same set of 25 students, and we're going to look at that same value of 86 and calculate its z-score. All right, so previously, I already put this data into the calculator. Okay, and calculated my mean, right? The x bar equals 80, and our standard deviation for our sample, the s sub x, equals 6.069047152. We'll round this to 6.07. Keep a couple decimal places. And those are the two numbers that I need to do this calculation. Okay, and we just simply put the data points, all 25, into the graphing calculator, starting at 67, ending at 93. We got our data. So we'll write this down. We had a mean, our x bar was 80. Right, our standard deviation, the s sub x, was approximately 6.07. So then our z-score for the observation of 86 will be 86 minus 80 divided by 6.07, which will be 6 over 6.07, which from previous calculations gets us approximately 0.99. So the student who scored an 86 has a standardized score of 0.99. Okay. That means the score of 86 is 0.99. And deviations greater than the mean. Okay? So a score of 86 is almost one standard deviation greater than the mean. We can have z-scores that are negative, right? If I were to use the score of 67, 67 minus 80 will give me a negative number, right? Negative 13. Negative 13 divided by 6.07 is going to give me some negative number. And that would imply that 67 is approximately, I mean, that's going to be right around 2 standard deviations less than the mean. So it's going to be to the left of the mean on our, if we're looking at the graph, right? And so what this allows us to do is relate all of the scores to the mean and how far away they are to the mean in terms of standard deviation. And so that standard deviation can allow us, right, the reason we're looking at this is because that z-score can allow us to look at different sets of data that may be scored differently, right? If I standardize it, I can compare everything that's been standardized by how far away it is from the mean. And so that's how we can end up using this in the future, is to compare different data sets. Right? Because there's tests like the SAT and the ACT that are scored on different scales. We can standardize those results and then compare them to see, okay, well, which one is more varied? Right? Well, okay, well, the standard deviation for the ACT, you know, we might have more scores within one standard deviation than we do on the SAT. That would be a way to compare. So that's why we use this standardized scoring. It allows us to compare things that were measured differently by standardizing them to how far away are they from the mean in terms of standard deviation. Okay. What can I clarify for you? Does anyone need a moment to write anything down from this screen? Please raise your hand.
Wait, can you explain how you got the 6.07?
Yes. So the 6.07 is the standard deviation. Now, what we did in earlier today when I entered this in for the first time is I actually just got this by putting my data into the calculator. Right? I put all of these scores into list 5, 67, 72, 73, 73, 74, 75, 77, 78, 79, 79, so on. All these scores are entered into list 5. All right, then I went to calculate, one variable statistics. List 5 is still in here because that's the one I did. We calculated it. Right? And once again, the standard deviation is the average distance of my observations from the mean. So it's kind of like the example we saw Tuesday, right? We did it with much fewer data points or less observations. This has 25. It would take a lot longer to create that table. But for each observation, essentially what occurred within the calculator is that we took the number, subtracted the mean, and then squared the number. Right? And so, like, for example, with 67, I subtract the mean, I get 13. Then I would say 13 squared. Right? And that's going to give me some number. I think it's, what's 13 squared? I don't remember. 139 or something? I can't remember. I think I'm wrong. Either way.
Oh,
Just remember.
is the steps of doing it in the calculator gonna be on the like canvas somewhere? Because you know the steps to do it.
Yeah. I have not. Well, I've shown the steps on how to get to the one variable statistics in one of my previous videos for one of the other, like creating histograms or something. But I can specifically show just how to input a list as to one variable statistics if that's something you'd like. Just like a short little video. Yeah. Okay. Let me write it down.
Thank you.
I've got my sticky note of video suggestions, so I will add that. Thank you. All right. Awesome. Thank you. Okay. But yeah, so you should be able to get to this screen. That's going to be important when it comes to just answering questions, because sometimes you're not going to need to like show all the steps, right? As far as like doing it by hand, but you will need the values to do other calculations, such as this example where like we could take the time and calculate the mean and the standard deviation by hand. It would probably take like 20 minutes or so. But that we don't need to. We just need the numbers, so we're going to have the calculator do the legwork. So that we can get into the calculation that we actually need. Yeah. Okay. Any other questions? Thank you for asking your question. Good. All right. So next, we're going to do an interactive part of the lesson, something that I'm trying today. It worked out pretty well in the first two classes today, in period 1 and period 3. Let's see if you guys can do just as good. So I need to end my slideshow. Yes, let me keep my notations. Do that. When thinking. Right. So I'm going to put the link to log into this Pear Deck in the chat. You can click on that, and please log in using your school email and password for Google. Excellent. If you're having issues logging into this or you cannot access it, the link's not working, please tell me so I can help you. Give you a few minutes to get logged in, and then we will start. This activity is specifically geared toward just building a better understanding on percentiles. All right. To 15. So guys, please, this is a good opportunity to get to practice and get like feedback, right? So that you can see where you're at with understanding this stuff. So I encourage all of you to participate, because even if you're wrong, this is like a no risk type of thing. So there should be 27 of you guys. Where's the rest of you? I got 19. Come on, everybody. Wakey, wakey. Let's do some math. It's so much fun.
Would have been fun if I was in third.
If what?
If I would have been fun, it would have been fun for me in third. Right now, because
But I'm still here. You still got Mr. Mosley. I mean, it can't be that bad.
no, you're not wrong though.
All right. Ooh, actually, I'm up to that. 19, 20, 20. Okay. Only seeing one slide. Yep. That's okay if you're only seeing one slide. I haven't started it yet, so you shouldn't be able to answer any questions yet, Liliana. It's okay. All right. So if you have not quite logged in yet, please get logged in. I am going to start this thing. And boom. All right, so we are going to be looking at location and percentiles. Right? Percentiles are a way of saying or talking about the location of a specific observation or data point. Okay, and we introduced it today, so let's get to an example. All right, so you guys are going to use this stem plot. It's the same one from our presentation. It is the only stem plot we will be using today. And the only thing you're answering here is how many students scored below a 72? So you need to be able to read the stem plot. How many scores on this stem plot are less than 72? Not equal to or less than, only less than. Looking good so far. You can see that 6 of you have not attempted this yet. Please give it a shot. Let's see. Alrighty, so the correct answer for how many students scored below a 72 is 1. The only score less than 72 was 67. It can't be negative. There's only the one, right? We're not doing 72 or less. We're doing only less than 72. That's the important thing with percentiles and location is you have to look at everything that came before the point you're talking about, okay? Sure. Next. So if James, a student, scored a 72, what is his percentile? In other words, what percentage of students scored less than a 72? That percent is in the percentile for James. You may need a calculator here, or your phone, or something, to do a calculation. All right, and as a hint, the answer will be a single digit number that does not have any decimals. So once again, when we're finding the percentile, we need to find the percentage of scores that are less than the score I'm considering. Okay, we already know that there's only one score less than 72. And we have 25 observations. This means to find the percentage, we divide 1 by 25.
Can you repeat what you just said? Sorry.
That's okay. So recall from the first question, it asked us how many students scored less than 72, and the answer was 1, only 1, the score of 67. So that means when we're finding the percentile for James's score of 72, there's only 1 score less than 72. So the percentage of scores that were less than 72 in our distribution here is going to be 1, the only score, divided by the number of observations we had, which is 25. If we have 1 divided by 25, that will give us a decimal. We convert that to a percent, so that then we have the percentage of students who scored less than 72. We then make that into a th, right? A something's percentile, and that's the percentile for the score of 72. Hopefully I said it as eloquently as the first time. I don't know if I did. All right. So the correct answer would be 4th percentile, or just the number 4 within your response. Okay. And this is because 1 divided by 25 will be 0.04. We move that decimal place 2 spots over to the right, or multiply by 100, however you like to think of it in your head. And that lands us at 4, which means 4% of the scores were less than 72. And that means that James scored in the 4th percentile for this class of observations. All right. Let's try another one. This next one, we have another student, Katie. She scored a 93. What is her percentile? Once again, remember to first consider how many students scored less than 93. Okay, count up how many students got less than 93, divide that by 25, and convert to a percent. I see a lot of good responses so far.
Wait, how can you see ours? And
I have my own screen that I can see your results as you type them in.
oh, just put the number there and you see it.
Yeah.
Bro, I thought you had to enter and whatever. Oh, you know what? Never mind.
Yeah, I'm watching what you guys are typing in as you're doing it. Yeah. All right. So the correct percentile for Katie is the 96th percentile. Once again, we got this because there are 24 observations that were less than 93. Everyone's score except for Katie's 93. 24 divided by 25 is 0.96. Multiply that by 100 to change it to a percentage, which is 96%. So 96% of the students scored less than 93, which then means the score of 93 is in the 96th percentile. All right. Notice that we don't ever really hit 100th percentile, right? Because that would mean that if we landed at the 100th percentile, that would mean everyone had a score less than that number, which means that no one got that score. And so if we're representing a value that exists, a score that someone actually achieves, they're not calculated into that percentile, so it will never be exactly 100%. So it will always be something slightly less than 100%. Okay. Let's try another one. In this case, we have two students. They scored an 80. What percentile is the score of 80? Again, our first step is to consider how many students scored less than 80. Do not count the scores of 80. Only count the ones that are smaller than 80.
I think I'm wrong on mine.
I'll check in just a second. I'm typing something real quick. No, look. Okay. Valentina, I'm putting feedback into your little window here, so give me just a second. I'll finish typing it.
Just say it to me. I know I'm wrong.
Hey. Ooh, excellent. All right. So for this one, we have 12 values less than 80. Right, we have 67, 72, 73, 73, 74, 75, 77, 77, 77, 78, 79, 79. Okay, so we have 4, 5, and 7. Right, 4, 5, and 7 is 12. 12 divided by 25 will give us 0.48. That is 48%. So 48% of the scores were less than 80. So the score of 80, the two students who scored 80 are at the 48th percentile. All right. What questions do you have after doing these examples? What can I clarify?
So you wouldn't normally count the number that it's being asked for, like This example, like scored 80, you wouldn't normally count those numbers?
No, you do not when calculating the percentile, no. The number you're considering gets excluded from the count. So like you're saying the 80 in this one, we don't count that as part of what we're using to calculate the percent. We only do the numbers that are strictly less than that number.
Okay.
Does that make sense? Did I explain it to where you understood it makes sense?
Yeah.
Okay.
Thank you.
I worry sometimes that what makes sense to me up here doesn't make sense to you guys up there. So you gotta tell me. What else can I clarify for you guys? Percentile, we found essentially the percent of students who got a lower score than the one given. Yes, that is exactly what it is. The percentile we find is the percent of students who got a lower score than the one given. Yes, that is what percentile translates to. It allows us to say other things than just that piece of information. Like we can say, in this case, these students are at the 48th percentile. This means that 48% of students scored less than 80. Also, 52% of students scored 80 or better, right? So we can use that to say a couple different things about the data at that point. But it specifically has to do with how many scores or how many observations were less than the one we're considering. Very good question, Lally. Thank you. Anything else I can clarify? Okay. In that case, we're going to end our little pair deck session. Second to that. Okay. Excellent. So, exit there. Let's go do this. I'm going to go here. Last thing, I just want to do a quick review of what is left on this week. Obviously, we've made it through Monday, Tuesday, and Wednesday. It is Thursday. I'll be updating the live class resources with the notes and then the video as soon as it's all done being processed. It usually takes a little bit of time. And we have our discussion board of what's the percentile. You will definitely use what we just went over. The previous discussion board is starting 5. And we have our Chapter 1 self-assessment that is now available. A quick preview of the disc. This is formatted the same way as the Chapter 4 self-assessment. However, in this case, I decided to have 2 parts to the free response question because I wanted to make sure that I covered categorical data and quantitative data. Those are the 2 major themes in Chapter 1. So there's a question for each of those. I suggest, I think it just might be easier to do, to just kind of write out your responses and do your work on paper, and then take a picture of it and upload that picture into your text entry, right? I think you can, can upload an image if you're using the text editor. It just might be easier. It doesn't mean you have to do it that way. If you'd like to use the text entry, type stuff in, use tables, and then import or upload an image of a graph that you made on Staplet, you can do that, right? And just wanted to make sure you know that there's different ways you can submit your answer in this. Whatever's easier for you to accomplish, you should do, okay? So we have this. We have the reflection part. Again, I really just want your reflection about what was working, what didn't work, what would have helped. The same things as we did in Chapter 4's reflection. And then your self-assessment. Place yourself on the rubric somewhere based on where your current understanding of Chapter 1 is. All right? Please make sure that you check all the boxes that apply. If you're at a level 3, click 3, 2, and 1. Don't click 0. In my opinion, if you're doing this, you're not at a 0. All right? So I shouldn't get any zeros. If you only click the 1, when it auto grades, right, it'll give you an initial score of a 1 because you only clicked one box. Don't worry, obviously I go back into these and check and make sure that the scores are correct. It just makes it a little easier when I'm first going through these to have a good idea of what you believe your understanding is. Not super important detail, but, you know. All right. And that is it. Those are the things that I wanted to go over.